Alright, in this video we're going to multiply and divide rational expressions. Now, we remember how to multiply rational expressions because rational expressions are really just the same thing as fractions. So recall when you're multiplying fractions, if you have a over b times c over d. Everybody remember how to multiply fractions? That's right, you just multiply straight across. So you get a times c over b times d. And then you might have learned some other things you could do, like factoring and canceling stuff out, that you could do ahead of time. Well, that's what we're going to do now. So let's start with, let's see this one, x squared divided by x squared minus 4. And we're going to multiply that times x squared minus 5x plus 6 divided by x squared minus 3x. Alright, so there, the two rational expressions we're multiplying together. Now, one thing you could do is literally, yes, multiply straight across. Distribute that x squared through to all of those and get x to the fourth minus 5x cubed plus 6x squared. And then multiply x squared minus 4 times x squared minus 3x. So multiply all that stuff out on the bottom, then get this really big, ugly looking fraction. And then try to reduce that fraction like we did previously. Or we can do all of the simplifying ahead of time. So I think it's a good idea to factor everything. Factor all your numerators, all your denominators. Let's see what happens. Alright, so x squared, about as far as we can go. We don't need to write that as x times x. But x squared minus 4, that's the difference of two squares. So we can write that as x minus 2 times x plus 2. Times, alright, x squared minus 5x plus 6. So let's see, we got 1, so factors of 6. So x minus 2 and x minus 3. If you need to refresh your memory on factoring trinomials, by all means, check out that other video. And then the denominator, x squared minus 3x. We have two terms, and remember you always look for the greatest common factor, and we see that we've got one. So factor an x out, and you're left with x minus 3. Alright, so now, when we multiply these things together, we say, essentially we're just going to have all this stuff in the top and all this stuff in the bottom. And then we look to find common factors. Do we have any factor that's common to both the numerator and the denominator? Well, we can see right here that we have an x minus 3 in the top and an x minus 3 in the bottom. Well, those divide out and leave behind just a 1. So they go away. And then we notice, oh look, we've got an x minus 2 here and an x minus 2 down here. Well, those also will divide out and leave just a 1 behind. So now we're left with x squared times 1 all over x plus 2 times x on the bottom. But if you notice, we've got an x squared on top and an x on bottom. So that means one of these x's can go away and leaves just one of the x's up top. So you have x times 1, which is just x, and in the bottom you're left with just x plus 2. Now, we cannot divide these x's out because of the plus 2 thing. This x plus 2 is all one factor, and either all of it divides out or none of it divides out. So this is just as far as we get to go. Alright, let's try another one. Suppose we have 5x plus 5. 5x plus 5 over x minus 2. And we're multiplying that times x squared minus 4x plus 4 all over x squared minus 1. Alright, so same thing as before. Factor everything. So 5x plus 5, we can take a 5 out, and that leaves behind x plus 1. X minus 2 there's nothing to do there. It's already factored. Times x squared minus 4x plus 4. Right, that factors into x minus 2 times x minus 2 all over, and then x squared minus 1 is the difference of two squares, so x minus 1 times x plus 1. All right, and then we look, say, all right, do we have any common factors to the top and the bottom since this is multiplication? So yep, there's an x minus 2 right there and an x minus 2 right there. They divide out and leave one behind. We see an x plus 1 on top here and an x plus 1 on bottom there. They leave a 1 behind. So we're left with 5 times x minus 2 on the top divided by x minus 1 on the bottom. You could multiply that 5 through the top there if you would like, but there's really no reason to. Alright, so that's it for multiplication. Factor everything, divide out the common factors, the factors that are common to both the top and the bottom. So now what about division? Well, the good news is division, essentially we just change it into multiplication. Recall that A divided by B, and if you divide all of that by C divided by D, recall that we can rewrite that as A over B, change division to multiplication, and we do the reciprocal of that second fraction. So this goes to D over C, and then just treat it like a multiplication problem. So it's not any different than the two problems that we just had prior to this. So let's see an example. So let's look at 4x minus 8 divided by x plus 2, and all of that is divided by x minus 2 over x squared minus 4. Alright, now you could, a couple things you can do first. You could factor everything now and then change it to multiplication and go about your merry way. I caution you on doing that because it might be tempting to start dividing out factors that are common to both the top and the bottom somewhere too early. I think it's best to go ahead and rewrite this as multiplication first. So 4x minus 8 over x plus 2. Change this to multiplication, and we get x squared minus 4 over x minus 2. Change it to multiplication first and then go through your factoring and your simplifying. I think fewer mistakes will be made. So 4 times x minus 2 all over x plus 2 times x squared minus 4 factors into x minus 2 x plus 2 all over x minus 2. And then divide out common factors. We've got an x minus 2 and an x minus 2. We've got an x plus 2 and an x plus 2. Oh, so it looks like this thing is just left as 4 times x minus 2. And that's just as far as we can go. So the good news is division, no more difficult than multiplication. Just change division and multiplication first, then factor all your numerators and all your denominators, and then divide out any factors that are common to both your numerator and your denominator. Study well. Please let me know if you have any questions.